So in this discussion, we are looking at area between curves, and we are provided with two curves, y is equal to x squared and y is equal to x minus x squared. So we have just drawn the curves, just a sketch. We have not drawn, but we have just sketched a little bit something that is close to what is exact. So our x squared is symmetric about the y-axis, but it is passing through the origin. And also we see that the 2x minus x squared curve is also passing through the origin. But we need to find the point of intersection where the two curves cross each other. And at those points, the y values are the same. If you look at them, the y values are actually the same. The y value here is equal to the y value. I mean, the y value for this curve here is the same as the y value for this curve. Here, the y value for this curve is the same for this curve. That's what I'm talking about. And therefore, if I equate the two, I'll have x squared is equal to x minus x squared. Then 2x is still on this side of the equal sign. So I'll have 2x minus x squared, then minus this x squared, and is equal to 0. So 2x minus 2x squared is equal to 0. If I factorize out the 2x, which is common, I will have 2x into 1 minus x is equal to 0. Therefore, x is either equal to 0 or x is equal to 1. So meaning I'll start from 0 here to 1. So the area in between here is the one I'm interested in. But how do I reach there? That means I will need first get the integration for this curve between 0 to 1 to get the area between the x-axis and the curve 2x minus x squared. Later on, I also integrate the x squared curve between 0 and 1 to get the area impounded between this curve and the x-axis. So sorry about that. So now we are saying we get the area for this curve. This is what we are talking about. You have the area there for this curve here. So between 0 and 1. We get that area, then we also have another one for the other one of x squared. So from 0 also to 1. So I get this area minus that, I'll remain with that part there. So that's what I'm talking about. Therefore, the area between them will equal to integrating 2x minus x squared from 0 to 1 with respect to x minus integrating from 0 to 1 of x squared with respect to x. So this is going to be 2x squared out of 2 minus x cubed out of 3, 0 to 1. I subtract. The integral of that is going to be x cubed. So x cubed out of 3 from 0 to 1. Obviously, this is going to be 2, so that becomes x squared. So I'll put in 1, I'll have 1 squared minus 1 out of 3 cubed, 1 out of 1 cubed out of 3, then minus 0 because the whole of these ones are 0, then minus 1 out of 3. Of course, that was 1 cubed minus 0. So what is this going to give us? The area will therefore be 1 minus 1 out of 3 minus 1 out of. So this is 1 minus, this is 1 minus 2/3, and this is going to be 1 minus 2/3, and this gives us a third square. So the area in between the two curves is equal to a third